Good morning, friends. I hope you remember what we learned in the previous session. We found out what are sequences, and we also saw that sequences have a general pattern or a general formula. And once you know the formula, you can directly find out any term of the sequence. Then we also learned what are finite sequences and what are infinite sequences, and slowly we derived the formula of an arithmetic sequence. So I hope you remember what an arithmetic sequence is. Yes, an arithmetic sequence is a sequence in which the common difference remains constant. So here I have put a little exercise on the board. So we'll find out of the sequences which are arithmetic sequences and which are not. So let us progress. The first sequence looks like an arithmetic sequence, but it is not an arithmetic sequence. Yes, you guessed it right. 7 minus 7 gives us a 0. And 8 minus 7 gives us a 1. Since the differences are not constant, this is not an arithmetic progression. The next sequence we have minus 1, minus 1.5, minus 2, minus 2.5. Let us check the difference. The common difference of the first two terms is minus 1.5 minus minus 1. Minus 1.5 minus minus 1 is equal to minus 1.5 plus 1 is equal to minus 0.5. We try the next one. We have got minus 2 minus minus 1.5 equal to 2 plus, minus 2 plus 1.5, which gives us minus 0.5. Since the common difference of all these terms remain the same, this is an arithmetic sequence. Now let us move to the third sequence. We have 4 minus 5, that is minus 1, 6 minus 4, that is 2, 4 minus 6 is minus 2. Since the difference does not remain constant, this is not an arithmetic progression. The next one, 9 minus 4 gives us 5, 16 minus 9 gives us 7, 25 minus 16 gives us 9. The difference does not remain the same, so this is not an arithmetic sequence. Next we have 80 minus 90, that is minus 10, 70 minus 80, that is minus 10, and 60 minus 70, that is minus 10. Since the difference, okay, we go again. 80 minus 90 is minus 10, 70 minus 80 is minus 10, 60 minus 70 is minus 10. Since the common difference remains constant, this is an arithmetic sequence. For the next one, we have got 8 minus 8 equal to 0, 8 minus 8 equal to 0, 8 minus 8 equal to 0. We learned yesterday that the common difference can be 0. And when the common difference is 0, all the terms of the sequence remain the same. Yes, this is arithmetic sequence. Now we take one sequence which does not have numbers but have got variables. We have got a plus 1, a plus 2, a plus 3. But we apply the same method to check whether it is an arithmetic sequence or not. So what will we do? We take this term a plus 1 and we subtract the previous term a. So we get the common difference 1. Similarly, we'll go for this. We got a plus 2 minus the term a plus 1. When you open the brackets, you get a plus 2 minus a minus 1. So we got 2 minus 1, that is 1. Similarly, a plus 3 minus a plus 2, we have a plus 3 minus a minus 2, that is 1. So this is an arithmetic sequence with the first term a and the common difference d. Similarly, the next one, we have got a minus 2 minus a, which gives us a common difference of minus 2. The next one, we have got a minus 3 minus a minus 2, which gives us a minus 3 minus a plus 2, and minus 3 plus 2 is minus 1. Since the difference does not remain the same, this is not an arithmetic sequence. So I hope for this exercise you have understood to distinguish between arithmetic sequences and general sequences. Okay? Next exercise, we have some arithmetic sequences or arithmetic progressions written on the board. What are we going to do now is find out the first term of the sequence, the common difference of the sequence, and with the help of the first term and the common difference, we are going to find out the formula for the nth term of the sequence. So I'm making myself clear again. We have got this arithmetic sequences. We are already told that these are arithmetic sequences. What we will do is write down the first term of the sequence, find out the common difference of the sequence, and with the help of the first term and the common difference, we'll find out the formula of the general term of the sequence. So let us proceed. As you can see, the first term of the sequence is A. So I write down the first term is A. The common difference can be found out by subtracting any term by the succeeding term. So I can do 2a minus a or 3a minus 2a or whatever. So I'll do 2a minus a and I get a. So the common difference is also a. And now we proceed to the nth term or the general term. What do you have? We know the formula an equal to a plus n minus 1d. The first term is a. So I put the a plus n minus 1 and the common difference d is also a. So we have a on opening the bracket a into n, na, a into minus 1 minus a. The a and the minus a gets cut off. We are left with na. So na is the general term of this sequence. Let us check. Put n equal to 1, we get 1 into a. Put n equal to 2 for the second term, we have 2 into a, 2a. Put n equal to 3, we get 3a. So with the help of the first term and the common difference, we have derived the general term of the nth term of the sequence, the general formula. So now if I want to find the 75th term of this sequence, I put n equal to 75 and I know the 75th term of the sequence is 75a. This was very simple. Now we move on to this one. Let us see how it works. The first term of the sequence is minus 1.2. The common difference of the sequence is minus 3.2 minus 1.2, that is minus 3.2 plus 1.2 equal to minus 2. So for this sequence we have the first term is minus 1.2 and the common difference is minus 2. Now we proceed to derive the nth term of the sequence. Again using the formula a, the first term is minus 1.2 plus n minus 1 and the common difference d is minus 2. So what do we have here? Minus 1.2 minus 2 into n minus 2n and minus 2 into minus 1 gives us plus 2. So we have now 2 minus 1.2, that is 0.8 and minus 2n. This is the formula for the nth term of this sequence. Now let us check. When we put n equal to 1, 2 ones are 2. Putting n equal to 1, we have 2 ones are 2. So we have 0.8 minus 2 into 1 equal to 0.8 minus 2 and we get minus 1.2. So this has become the general formula for this sequence. Now there are 4 more sequences on the board and we have to proceed in the same manner. So we'll take some time and we'll finish this too. Okay, I'm going to leave this 3 for you to work upon and let us solve the last one now. I hope you will be able to do this. This is quite simple now, and since you've understood the formula and how to go about it, you will be easily able to solve it. We'll just finish the last one. The first term of the sequence is 1 upon 3. The common difference is 5 by 3 minus 1 upon 3. So we have 4 upon 3, the common difference. And the nth term is the first term, 1 by 3 plus n minus 1. The common difference is 4 upon 3. So we have 1 upon 3 plus 4n upon 3 minus 4 upon 3. So we get 4n upon 3. Now 1 by 3 minus 4 by 3 is minus 3 by 3, and minus 3 by 3 is minus 1. So the general term of this sequence is 4n by 3 minus 1. So let us check. When we put n equal to 1, putting n equal to 1, we have 4 into 1 4 upon 3 minus 1. And taking the LCM, you get 4 minus 3 upon 3 equal to 1 upon 3. So what have we done again? We have seen an arithmetic sequence, and what is the procedure we follow? We first find out the first term of the sequence which is given. We find out the common difference by subtracting a term from its succeeding term, and then using this formula which we learned before, we find the nth term of the sequence. So every arithmetic sequence has got a general nth term which can be found out. And how it makes our work easier than when we want to find out any term of the sequence. For example, we want to find out the 30th term of this sequence. So what formula had we got now? 4n by 3 minus 1. The nth term of the sequence will be, 30th term will be 4 into 30 upon 3 minus 1. 10. 4 tens are 40 minus 1 equal to 39. So 39 is the 30th term of this sequence. Since we have now derived the general formula of an arithmetic sequence, an equal to a plus n minus 1d, we are now going to apply this formula and do the sums based on this formula. So in example here, which term of the AP 120, 116, 112 is the first negative term? So as you can see, this is a decreasing sequence whose common difference is 116 minus 120 is equal to minus 4. We have to find out which is the first negative term of this sequence. Means which term of the sequence will be the first negative term. So we write down first. The first term, a is equal to 120. The common difference d is equal to minus 4. Now, you will see as we progress further, we will reach a 0. And after 0 comes the negative term. So we will try to find out which term of the sequence is 0. Using the formula an equal to a plus n minus 1d, we get an, that is 0, equal to a, that is 120, plus n minus 1, and the common difference d is minus 4. 120 moves to the left side, so it becomes 0 minus 120 equal to n minus 1 into minus 4. Minus 120 equal to n minus 1 into minus 4. Minus 4 is in multiplication, which goes into division. So 120 upon minus 4 equal to n minus 1. So we get 30 equal to n minus 1. Moving minus 1 to the right side, left side, 1 plus 30 equal to n. So n is equal to 31. Now this is not the answer. What you can see, the 31st term of the sequence is 0. And after 0 comes the first negative term. So the first negative term of the sequence will be the 32nd term. So the 32nd term of the sequence will be the first negative term of the sequence. Since we have now derived the general formula of an arithmetic sequence, an equal to a plus n minus 1d, we are now going to apply this formula and do the sums based on this formula. So in example here, which term of the AP 120, 116, 112 is the first negative term. So as you can see, this is a decreasing sequence whose common difference is 116 minus 120 is equal to minus 4. We have to find out which is the first negative term of this sequence. Means which term of the sequence will be the first negative term. So we write down first. The first term A is equal to 120. The common difference D is equal to minus 4. Now, you will see as we progress further, we will reach a 0. And after 0 comes a negative term. So we will try to find out which term of the sequence is 0. Using the formula an equal to a plus n minus 1d, we get an, that is 0, equal to a, that is 120, plus n minus 1, and the common difference d is minus 4. 120 moves to the left side, so it becomes 0 minus 120 equal to n minus 1 into minus 4. Minus 120 equal to n minus 1 into minus 4. Minus 4 is in multiplication, which goes into division. So 120 upon minus 4 equal to n minus 1. So we get 30 equal to n minus 1. Moving minus 1 to the left side, 1 plus 30 equal to n. So n is equal to 31. Now this is not the answer. What you can see, the 31st term of the sequence is 0. And after 0 comes the first negative term. So the first negative term of the sequence will be the 32nd term. So the 32nd term of the sequence will be the first negative term of the sequence. So now we've got another example for you. This example is asking, is 184 a term of this sequence? Means, look at this sequence. 3 plus 4 7 plus 4 11 plus 4 15, and we go on. Do we have the term 184 in that sequence is what we are supposed to find out. So let us say that 184 is the nth term of the sequence. We can assume the nth term of the sequence is 184. We have to find out which nth term will be 184. Again, we have to use the same formula. So first we'll find out A. As you can see, the first term of the sequence is 3, and the common difference D is equal to 7 minus 3, that is 4. Using this formula, an equal to 184 equal to A, that is 3 plus n minus 1 into 4. First we bring the 3 on the left side. So 184 minus 3 gives us n minus 1 into 4. 181 equal to n minus 1 into 4. 181 upon 4 equal to n minus 1. Now what do we get? 181 upon 4. Yes, that is 45.25 equal to n minus 1. So 45.25 plus 1 equal to n, which gives us n equal to 46.25. Now you can see what happens here. This is the first term of the sequence, the second term, the third term, and so on. So the nth term of a sequence should be a natural number. It should be 1 or 2 or 3 or 4. It should not be a negative term, or it should not be a fraction or a decimal number. Since this is a decimal number, it shows that 184 is not a part of the sequence. I repeat, the terms of the sequence, the first term, second term, third term. So n is equal to 1, or n is equal to 2, n is equal to 3, n is equal to 4, and so on. When n is a natural number, then the number is a part of the sequence. If n is not a natural number, if it is a negative number or a decimal fraction or a fraction, then it is not a part of the sequence. So as you can see, 184 is not the term of the sequence 3, 7, 11 and so on. We have one more question on the board now. This question asks, which term of the AP 3, 10, 17 will be 84 more than the 13th term? So we have to know the 13th term of the sequence, add 84 to it, and then we get the term. And we have to find out which term of the sequence is 84 more than the 13th term. But we can use a direct formula to find out which term will be the answer. How do we do that? Suppose the term which we have to find out is the anth term. So we are given the term an is 84 more than the 13th term. So we take the 13th term and add 84 to it. So what have we done? We have taken the 13th term and added 84 to it because we want to find the term which is 84 more than the 13th term. We are supposed to find this term which is 84 more than the 13th term. Now there are two unknowns in this formula. So we will simplify and try to reach the answer. For this an, we'll put down this formula a plus n minus 1 d. Now we know the 13th term, we already have understood the 13th term is given plus a plus 12d plus 84. Now what can you observe on both sides? This a is the same, so we cut it off and we are left with n minus 1 d. What is d of the sequence? 10 minus 3, that is 7, equal to 12, d is 7 plus 84. So we have n minus 1 to 7, 12 sevens are 84 plus 84. So now we have n minus 1 into 7 equal to 84 plus 84, that is 168. And therefore n minus 1 equal to 168 upon 7. So we get n minus 1 equal to 24 or n equal to 24 plus 1, n equal to 25. So the 25th term of this sequence will be 84 more than the 13th term. I hope you have followed this sum. We repeat once again. We have to find the term of the sequence which is 84 more than the 13th term. So we have taken the term which we are supposed to find as an and written down it is 84 more than the 13th term. Then putting down the formulae and the values, we have concluded this, that the 25th term of this sequence is 84 more than the 13th term. I hope it is clear to you. In this example we have the data given. 5 times the 5th term of an AP is equal to 8 times the 8th term. We have to show its 13th term is 0. So as you can see in this sum, we are not asked to find any values or any terms, but we have to assume an arithmetic progression, and then the condition given is 5 times the 5th term is equal to 8 times the 8th term, and we have to show its 13th term is 0. So first let us write down the data given to us. 5 times the 5th term is equal to 8 times the 8th term. Now, how do we write the 5th term? Based on this formula, a plus 5 minus 1 d, that is a plus 4d. And the 8th term is written as a plus 7d. On opening the bracket we have 5a plus 5 4s are 20d equal to 8 into a, 8a, plus 8 7s are 56d. Now we'll rearrange the terms on either side to get 8a, move it here, minus 5a plus 56d minus 20d is 0. So we have 0 equal to 8 minus 5, 3a, plus 56 minus 20, that is 36d. Now we take out the 3 common, so we get a plus 12d. Now from here, we take the 3 in the denominator, so 0 by 3 equal to a plus 12d. But 0 by 3 is 0, so 0 equal to a plus 12d. Now what is a plus 12d? Yes, a plus 12d is the 13th term, so we have 0 equal to a 13, and hence we have proved the 13th term is 0. So here is some data given with which we have to show that the 13th term is 0. We have used the same formula. We have not found any values. We don't need to know the first term also. We don't need to know the common difference also. This sum doesn't need you. This sum doesn't want you to find the values. You only have to prove that the 13th sum is 0. So we can assume an AP whose first term is given A and common difference is given D, and then by going in a sequence we can show that the 13th term is 0. Example, we have to find the 7th term from the end of the AP which is given to us. Now you can see this is a finite sequence which has got a last term. So we have to find the 7th term from the end of the AP. Now if you observe this AP, you will see the first term of the AP is 7 and the common difference of this AP is 3. Now what do we do if we want to find the term from the end? What we can do is we can write this AP in reverse, where 184 becomes the first term, then we have got the succeeding terms which ends with 13, 10 and 7. Right? Now to find the 7th term from the end is finding the 7th term from the front of the reverse sequence. So now we have A equal to 184 and D is equal to, what will the D be? In the sequence we had, the D was increasing by 3. So when we move in reverse, the D decreases by 3, so D becomes minus 3. So the 7th term now is given by A plus 7 minus 1 D. So that is A plus 6D. The A given is 184, 6. Now D we have is minus 3. So the 7th term will be 184 minus 18. What do we get? 6, 6, 1. So the 7th term of this sequence is 166, is also the 7th term from the end of the sequence given to us. So this is one more way we can use this formula to find the sequence either from the front or from the end of the AP. But remember, when you have to find from the end of the AP, it has to be a finite sequence where the last term is given. In this example, the data given is the 8th term of any AP is 0. We have to prove its 38th term is 3 times the 18th term. So let us begin the sum using the same logic we have used so far, and I hope by now you have understood how the sums are done and you might be able to do it before me. I will do the sum on the board for you, but you can also try with your own self to see if you can do it. So let us begin now. We are given the 8th term of an AP is 0. So the 8th term given to us by the formula is A plus 7D. We are given the 8th term is 0. So 0 equal to A plus 7D. So here we have, by rearranging, A equal to minus 7D. This is what we get from the data given to us. The 8th term of an AP is 0. So the first term will be minus 7D, whatever the D is. Now we move to the 38th term. The 38th term of this AP will be A plus 37D. But what did we find out the value of A? Minus 7D. So I put down the value, minus 7D plus 37D gives me 30D. Okay, so we have got a 38th term. Now we'll find the 18th term. The 18th term of this sequence, A18, will be A plus 17D. But what is A again? Minus 7D. adding 17d, we get 10d. So now what have you got? 3 times the 18th term. So 3 times the 18th term is 3 into 10d. Because 18th term is 10d, we get 30d. But 30d is also the 30th term. So we have proved in this sequence 3 times the 18th term is also the 30th term. So this is one more way we are using this formula to prove what we need to prove. So now we have understood the various ways in which we have used this very formula, an equal to a plus n minus 1d, the general formula of an arithmetic sequence, and done very different kind of sums. Now we are going to leave you some exercises for you, which is put in the module, so you can try them out, and in case there is any doubt, you can revert back to us whenever you need. Thank you.